Hello and welcome to another video. So today I'm going to be explaining why you may be killing your fish by using or doing water changes with dechlorinated water. So you might use one of these products. Chem Prime is a popular one, or API tap water conditioner. And so basically it says dechlorinates aquarium water and removes chlorine. Chloramines, I'm not going to worry about heavy metals. But you might have basically no idea what that's talking about. And honestly, it's sort of incorrect. So first of all, I'm going to just go over chloramine because that's mainly what the US uses to basically remove organic impurities from the water. And so basically, if you're from Denmark or something, I'm pretty sure they don't do that there. But if you're in the US and you have a fish tank, this completely applies to you. So I'm going to start off by drawing the molecular formula of chloramine. And this is a Lewis structure, so obviously it's inaccurate. And I'm not even going to draw lone pairs. If you have no idea what I'm talking about, don't worry. Basically, this is what a chloramine molecule looks like. So this part is a chlorine, it's like that, Cl, it's chlorine. And this part is the amine. So basically, chloramine is made of these two parts. And the thing is, it's very bad for your fish. So what people normally do is they take a dechlorinator, right? And it says, oh, it removes chlorine and chloramine. So I'm not gonna go over chlorine, but for chloramine, basically, what it's doing is it has some sulfurous compound. It's not listed. It doesn't really have ingredients or anything. So I'm not really going to go into many details about that. But basically what it does is it splits this and it separates it into the chlorine ion, which is known to be harmless to fish because it's stable in its ionic form, not very electronegative. And then it's broken into NH, and this is going to have a negative charge. And the thing is, because this is a covalent molecule, especially with nitrogen, being in water, it's not going to want to stay this way. So I believe, I'm not 100% sure on this, but in some way, when they dechlorinate this, this is actually converted into normal ammonia. And so if you've been keeping fish, you may have heard of ammonia. NH3, that's the scientific name for it. And there's also lone pairs, I'm not going to include that. And basically, ammonia is a necessary ingredient to life, but it is also like window cleaner. So it is not good for many organic things. And it's used as plant fertilizers, but unfortunately, your fish are not plants. So usually, when you have a tank set up, you're going to have some sort of filtration, beneficial bacteria that'll convert this ammonia into nitrite and nitrate. And so this is converted into nitrite, which is converted into nitrate, which then hopefully your plants can eat up. So now that we understand kind of how this dechlorinating process works, let's also talk about what it says when it says detoxifies ammonia, nitrite, and nitrate. So I'm not going to talk about nitrite and nitrate. I'm not sure if it actually really does anything besides having dead bacteria in here, I've heard. But detoxifying ammonia, what it is doing is it is taking this and it is actually turning it into a hydronium ion by adding an H. So then it becomes I'm going to write NH4 plus. And because this is in its ionic form, it's going to be less harmful to your fish. But that doesn't mean it's not going to be harmful, but it's just less harmful than this because it's more stable as an ion or something like that. Basically, what I'm trying to get at here is when you are using a dechlorinator, however much concentration of chloramine that's in your water supply, usually it's 1 to 2 ppm if you're in the US, especially in a city, that's going to be converted directly into ammonium ion. And so if you're doing, for example, 100% water change, dumping 2 ppm of ammonium ion into your tank, that could kill your fish, especially if you have like some weak fish. If you have, I don't know, fancy goldfish, tropical fish, anything like that. If you have like just like common goldfish, you might be fine, you might be able to get away with it. If you have a really good filter, you might be able to get away with it. But basically, my point is, when you're dechlorinating this, the product is still not great for your fish, right? And so eventually, what's going to happen is this NH4 is going to be turned into nitrite, which is like NO3 something, NO2, and then nitrate, which is NO3. And so ppm is calculated in milligrams per liter, right? So basically, the relative masses of each of these are going to figure out how many ppms of each of these it will create. So let's say we're starting with 2 ppm. This has a mass of what, like 18-ish maybe. This has a mass of like, let's say like 40, 45 maybe. This one would have 16 added onto that. That's what, 60, 61. So basically the ratio is very roughly 1 to 2 to 3. So if you're adding 2 ppm dechlorinated water, 2 ppm chloramine water, dechlorinating it, and it gets converted into nitrate, you're gonna end up with 6 ppm nitrate in your tank. And obviously nitrate isn't bad for your tank, but this is basically saying if your tap water is 1 to 2 ppm and you test your tank water and the nitrate content is the ammonia content is under 2 ppm, do not do a water change, because that'll just create more ammonia in your tank. And same goes with nitrate. If your nitrite is under 2 ppm, or in this case, if you have 2 ppm tap water, if it's under 4 ppm, then you're not going to want to do a water change. Same thing with nitrate, 6 ppm, not going to want to do a water change. So you might be thinking, wow, that sounds like a lot of stuff. What if I have like kind of high, like for example, like 4 ppm nitrite? That's going to kill your fish. So if you're wondering, what should I do if I can't just do a water change now? What I would recommend is the process called aging your water. So what that entails is having, I don't know, like a 5-gallon bucket, fill it up with some tap water, dump in the appropriate amount of tap water conditioner, whatever you're using. And basically that's going to turn the chloramine again into Cl ions and NH4 plus ions. And so these eventually, if you leave it out for, let's say, a day, 24 hours, these will all evaporate, dissipate into the atmosphere. And you can check if it's free of ammonia by doing another test on this water. And once it is, then you can add that into your tank, and it will not be converted into anything because it is going to be completely rid of ammonium ion. And yeah, but if you're not trying to do all that, if you have very strong filtration, I would recommend just doing like 10% water changes if you're going to do any water changes at all. If you have very weak fish, like fancy goldfish, for example, I would recommend aging process, especially if they're from overseas, because usually they're raised in pretty good places, with pretty good water quality. So if you're dumping them into 2 ppm ammonium ion right as you get them, obviously they're not going to be faring too well. But that's basically all I wanted to talk about. If you have any questions, if you have any questions, you can comment them. Obviously, this is just a YouTube video. I'm not saying everything I've said here is 100% fact. This is just based on observations and theoretical chemistry work. But if you're having problems where you see after you do a water change, your fish are acting sluggish, acting weird, dying even, this is probably the reason why, assuming you're using your dechlorinator properly. So thank you if you made it this far. Thanks for watching. Let me know if you have any other questions, and I'll see you in the next one.